Hello. Um, Today I will do the industrial plant genomics. Um, Let me start the Jupyter. What was that? I plant. Okay. Running Jupyter lab. Uh, First of all, I allow the sudo permission, and running Jupyter lab allowing root. Better. So let's copy this URL to to the web browser Chrome. Then you will find the code that we built last time, and now we'll run again every cells until it become blank, right? So run. Everything should be okay. So what we've done last time was that we extract the promoter upstream region of the gene with regard to the gene model of laboratory, and we also downloaded the database of plant promoter from software homepage, and we blast it, right? So we blast it. Okay. So this file was robot. Oh my. This laboratory promoter pasta and blah blah blah, and out 7 was the result of our blast. So the thing was that we have to I was thinking that we already learned. I was thinking that hold on. So we have these file. So yes. So we need to change the file name. Change file name. This was not last one. No. So this was the last one. And run. Okay. Save it again. And we will see the distribution of alignment ranks. Okay, so alignment length is like 20 or 15 is the modal value of the alignment length, and we load the sequence of 3 promoter pasta and all LPR sequences. What was the PLPR all? So this is the promoter database, and this is the promoter regional robot tree, and we could list the blast output data table, and we reformatted the output on this command, and we extracted the sequences using this definition, and we finally retrieve the curated data frame of blast output. So we can, I think we can see the data frame using head. Let's wait for a while. It takes time. So usually if you do the apply the method, this is actually same as the iteration, like a for loop. So it takes a lot of time. Or this is not broadcasting, this is iteration. So it takes a lot of time. But we have a lot of time, so let's wait. Okay, it is done. Okay, so what we have done, you can see we have query accession, subject accession, and the identity, and start point and end point of query, and the length of alignment, and the sequences of from the query and target, right? Query and target. So you can see how different it is and how similar it is. And also this means that this sequence block ranging 10 or 20, 15 or 20 is well conserved. You can determine by yourself by the structure of this. Okay, this is usually you can recognize Tata box, because Tata box is sometimes very well conserved. Okay. So last time what we have done was what we didn't do yet was parsing the information of the gene name of the promoter. So because we have this accession version, so we can extract this gene information or product information from this original file. So this is original file. So this original file contains this information, and also it has information of promoter promoter description. So Tata, or sometimes it will call it, so everything is Tata or not. So mostly it is Tata. So it is not that useful, I think. Let's check more systematically. Okay, let me build this information into table. Okay, so the ID of this promoter will be the first one. So everything is split by dot 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 dot. This is a very weird scheme, but they built in this way. So let's split this using dot dot. And for each in promoter info, and we can split with dot dot. Let's let me use just one or two case, and you can see, okay, we have this information. Then maybe we can name it. Maybe we can name it dictionary. The first one will be promoter ID, right? And second one will be just accession name. I think that is the gene bank accession. Let me check. NCBI. Okay, right? So this is the gene bank accession. So I will change this as gene bank. Okay. And next one is organism. Gene name, I would say. Next one. They say product. I don't know what product is different from gene name, but no problem. And the promoter range, right? And what is the CDS plus? What is CDS plus? CDS plus. I don't know. I would say just put it here. CDS and TSS. Okay. Okay, that's it. So it's saying that TSS. This must be transcription starting site. Transcription starting site. Taxon, promoter. I would say put just info. Okay. Cool. Then each list is right this and promoter ID equal each list 0 dictionary gene bank each list 1 dictionary organism each list 2 what was that gene name? Product for dictionary promoter range. Promoter range, what do we find? Dictionary list 6 dictionary and 4 list. So this 7. Okay, it's none, and you can check dictionary like this. Okay. Oh, append. I should have put here append rather than equal, because I already assign list there, empty list there. I should have append. Yeah. This is why sometimes labels, even we are code to avoid labels stops. But once you build everything with this labels works, then you will be free. Okay, so this is the thing, and I will free everything. So import is try import and accept index error. Let me see what happened. Yeah, print each. Okay. So last one. Huh. This is problem. This is problem. Because I was thinking that everything has its own gene part, right? So I was thinking that everything should have its own gene part, but it was not. So, which means I have to change the scheme of mine, right? Wow. This is not good. Okay. Okay. Then let me change everything. I will delete everything. I will delete everything. I will start from here. So if you merely split it, then it will gives you like this. And I will change my strategy. Let's split first this one. Let's split first this one. Then you will have 32 transcript start font is trend. So sometimes it doesn't have any description, but in this case it has some kind of command like this. Then I will ignore everything which don't have any key. Okay, I will ignore any information without key. So this is key. So this is the key. So this is also key, right? So this is the way. Then how can I do? I will split this one. And the first one should be split by that also. Each list, this was each list 1, this list 2 should be 1, 0, split by ding ding. So each list will be each list 1 plus each list 2. No, let me print and see. List, right? Then now it has this one and that one. Okay. I used already 0, so I will use anything beside 0. Let me move this one to here. Okay, so I know that first one, for x in each list, x split by this one. If in x, print. Oh yeah, okay, then we can change this into diction. No, why? Let me check. So okay. If that's in there, okay. Each list first. Temp for x in each list. Temp x if length n s will be 2. Dict print. So temp dict. What? Okay. Right. So temp dict. So we made temporary dict. But this is a bit weird, but I don't care because I will use my own scheme. Accession, organism, gene, CDS, and what is this? So I will ignore CSS, TSS, also taxon I will use, and promoter information I will use, and also ID, another ID, product and plant promoter database. Okay, dictionary and ID will be list 0 and dictionary AC would be temp dict AC. Dictionary OS dict OS and gene CDS. Okay, dictionary promoter temp dict promoter, right? Okay, let me see the dict. Offense. Sorry. Sometimes this is so stressful, but this is part of our job. Okay, so it was successfully applied. I will remove everything here. Oh no. Let me check it again. Always happening. Except key error. Print H and okay, this is error. So sometimes people raise some kind of error when you type in the data because so this is the evidence. Somebody actually coded this information in this database. Then I will ignore these errors rather than using every information. Okay. Try. Accept key error. Then this is not good. This is not good. Okay. So I think it will not happen for the ID, but it will happen for the AC. So accept key error. Then dictionary AC and not available. Copy this. Try. Accept key error. Dictionary dictionary os and na try except key error dictionary gene try accept and dictionary cds and this one try except key error dictionary taxon and none try except key error dictionary promoter and none 됐다. So now we have dictionary containing everything. I will change this dictionary into table. Okay, data frame dictionary, then data frame. What is this? This is the information of plant promoter db. Then you can list up the information. Okay, I don't like this symbol kokse. I want to remove this kokse. Okay, then you can replace the kokse to blank. And now you don't have any kokse here. Okay, you have ID and accession number of gene bank and organism and gene name product. Okay. No problem. So and taxon and promoter, right? So Chlamydomonas is not planted. Also, it say other plant. Tatares. Then let's join this table to our blast output. Okay, so our blast output that is curated is shaped like this, right? And we can extract the ID from where subject accession version. So again, apply lambda x can split using dot dot and zero. First one is the ID. Ah, my eye. Right? So now I have ID here, and we can add this information to here. So what kind of information you want to add? I'd like to add the gene information and promoter information. Okay. So the gene would be, and I will index it, set index and ID, right? So I can check the location using lambda again. So ID, I will use the ID information, apply, and lambda making new function. So ID will be supplied to here. Something is wrong. I'm sorry. So I was saying I will retrieve the gene information, right? So let's wait for a while, and it will give us because the reason why this is a bit slow, so I'm not using the server environment rather than I using my laptop environment, which is not so fast. You guys have server in your own lab, your lab, then it will faster than this. But this takes too much time than expected. Okay. I think something is wrong. I think something is wrong. Why? I will use more index function than using iteration. So this is how you use this index function. Values, then right. So and then you select gene, right? So you have genes. This can go to here, right? So it happened in quick manner. So let's check if this is really MPI or not. So this is the way you don't use any iteration. So this is MPI, okay. So next one. So this one, let me check. Okay, GH3, okay. And also you can add promoter right, data blast out curated promoter, so you can list up the information. So I think it only have Tata or Tataless. Let me me check. Promoter and value count. Right? So only Tata or Tatares. So maybe Tata. If you select only Tatares, blast curated masked. Ah. Why? Rated Tata S. Maybe it have another blank, right? No. What happened? Promoter. Sorry. Why? This is weird. Weird. Okay, it has blank here. This is not good. Okay. So then you can find non-Tata upstream component here. Okay. Then you can session version. So this is query sequence. So query sequence. Okay, this is really good. Okay, but I really do not like having blank there. So I will remove it. So X strip. And Tatares and promoter, right? And first one. So there's no blank at all. Good. Now we successfully created this table with query accession and subject accession and the hit blocks and ID, engine name. So this is subject name. So this promoter information coming from MPI gene. Maybe we have to add the organism information here also. And the promoter type is non-Tata, right? So this is how we build this information. Okay, today so I'm stop here. I will continue in next video. Bye bye.